Good evening, everyone. My name is Joe. So my goal today is to share a bit about the team that I work for and how we combine the red and blue security perspectives. But before I jump into that, I'm going to share a little bit about my background as I feel it's relevant to this conversation. So I spent the first 15 years of my career as a penetration tester and security consultant. And I was very fortunate to be part of an amazing team in Madison during the early days of the security industry. And during that time, we contributed a number of tools and content to the community under the FUFUS name. And this included the password guesser Medusa, the password hash liberator FGDump, and a bunch of other useful scripts and tricks. I recently heard these referred to as boomer tools, but I still take great pride in my contributions at that time to them. And then about 10 years ago, I left pen testing to join a large healthcare software company. Specifically, I work within its hosting division where we provide our software as a PaaS solution to hospitals, clinics, and other healthcare-related orgs. Now, I made a lot of recommendations on paper as a consultant to various clients. A key reason for my change was to see firsthand what it took to actually implement those controls in a real-world scenario. And then, as an extra kind of benefit reward, I now get to create very challenging obstacles and just make life very hard for our pen testers. So for me, there are really two separate worlds in security. There's a red one and a blue one. And as a red teamer, one is hired to test existing security controls, right? They attempt to answer questions of whether they can evade some sort of protection. Can they compromise credentials? Can they elevate their access to gain further inroads? Basically, the red teamer, well, they get hired to do what others might go to jail for doing. And they also, through that, develop this deep knowledge into what a real attack might look like. And they prioritize vulnerabilities then in ways that give them clear paths to things they care about, for example, domain admin. Now, that being said, the deliverable here isn't the hacking of something, but the report on how to fix it and why that actually matters. And that's usually where the fun might end, right? Because these reports, they're often used simply to check a box, and their recommendations aren't actually implemented. For me, it was a major point of burnout and why I ultimately left. And I found myself just asking the question of what I was doing. Was it really providing real value? Now, as a blue teamer, we often prioritize our security efforts based on a bunch of different sources of information, usually discrete lists. For example, we have vulnerability scanner output, right? We have configuration benchmark checklists, compliance requirements, or maybe internal lists that prioritize some asset based on business context. There's value in all of this information. However, it's an often overwhelming amount of data, and it begs the question of whether we can really use it intelligently. On the blue team, we also have the challenge of implementing our controls. And our prioritization, well, it's based on our own time, ensuring availability, meeting compliance requirements, and finally, dealing with the real security impact. Now, I don't have the answers necessarily how to always bridge the gap between blue and red, but what I can do is share a bit about how we look at security where I work. Specifically, how we try to find that magical kind of purple mix. I'm going to start out by laying out several discrete attack components before combining them in hopefully interesting ways. The first step in my hypothetical attack is password guessing. Red teamers, they're probably going to mock password spraying. They're going to say that, well, you're likely to get caught, it's noisy, and so forth. And my experience, I'll admit, is dated, but this was never a problem I ran into. So my preference is that we do a shallow attack, right? We send a very small number of passwords against a very large list of users. And this approach I found to be incredibly effective and generally will fly under any radar. It's why we wrote Medusa 20 years ago, because 0 days, they're great fun and all, but their life is generally short-lived. Users picking stupid passwords, that, my friends, that's timeless. And to be sure, MFA and all that is improved, but it's not everywhere, and it's not always foolproof, as the previous talk just mentioned. And we're now, as I show here, in what I consider prime spring 23 season, that I am incredibly confident if you look at any company out there, they have at least one, maybe many more people with a password of spring 2023 at this point. I'm going to pick on Citrix next in my example. So I'm in healthcare IT. Citrix, it's everywhere. And it's been that way for 20 years, and it's going to continue for many more. So as a very quick refresher, in a Citrix environment, the end user does not have the application installed locally. The application and all its configuration and data reside on the remote server. The user, they simply send keystrokes and mouse clicks to that server, and they get back screen updates. And our users, nurses and doctors, well, they're incredibly mobile, moving from exam room to exam room. And they'll log into some thin client, and they'll get access to their tools via Citrix. And this approach, then, it provides them easy session movement, it gives us centralized management, and overall cost of endpoint reduction. An individual hospital, it can have hundreds or thousands of concurrent Citrix sessions. On the flip side, Citrix is a favorite target of penetration testers, right? It's sometimes exposed to the internet and at least to a less trusted network. And Citrix is nearly impossible to fully secure. I would argue that the technology is just dated at this point, and it's from a gentler time in our history. And remember that that application and the actions are happening on the Citrix server, not the workstation. So if that server is compromised, well, the attacker is potentially behind the firewall and able to act within the environment. So let's assume that I compromised an employee at a hospital through my password guessing effort. And then I used their account to log on to an internet-facing Citrix portal. This can be bad in and of itself, right? I can potentially abuse published tools such as this EHR application to get to sensitive data. In this case, though, I'm an attacker with larger ambitions. I want to compromise the entire organization. And I'm going to continue down my path by breaking out of this app. So in it, we see this import option. And what that does is it takes us to a standard Windows file dialog box. And here as an attacker, I can now peruse the local file system of that remote Citrix server. And then, rather than importing a file as intended by the application, I can use a simple drag and drop type action to execute PowerShell. And it provides me with an interactive prompt on the remote Citrix server. And the important thing to remember here is that that command prompt, it's on the server, it's not on my workstation. And there's going to be many, many ways to break out of any published app. And the more complicated that piece of software is, the more possibilities will exist. So at this point, I have an interactive prompt within the target organization. However, I'm still just a non-privileged user in the domain. So to continue down our path, I need to elevate my rights and gain administrative control of the server. In the past few years, we've seen zero-day privilege escalation exploits drop roughly once every 6 months. The first here exploited a bug in the native task scheduling service that allowed a normal user to run things as an admin. And it's a bit dated at this point. However, I mention it because it's a good example of the logic behind some of the controls I'll discuss later. So let's assume that I've elevated my rights and I'm now an admin on the Citrix server. What am I going to do? Well, for me, I'm going to steal credentials of other logged in domain users as well as local accounts. Back in the day, we wrote FGDump to do just this. Today, tools like Mimikatz and others might be used. And this sort of action is especially important on shared systems like Citrix servers. Many people will be logged into at once. And their credentials, those might be in clear text in memory, or maybe they're stored as one-way hashes on the system. From an attacker perspective, it doesn't actually matter. I can use either to connect as that person to some resource. Microsoft Windows, it has this beautiful design flaw where you can use a password hash in lieu of the actual password to authenticate to something. We call it passing the hash. What we saw here was Medusa spraying a single hash against a very long list of computers and identifying which of them had that hash assigned to its local administrator account. And if you look then beyond those local accounts, logged in users are also especially handy. Tools like Bloodhound, well, they make finding those sessions and then identifying where they can be abused incredibly easy. So in this scenario, let's assume that I stole some creds, I sprayed them, and I was able to start moving across the domain, and I stole additional creds, and I could strategically hop at that point. And if we start to connect these discrete paths, well, things just get more interesting, right? Because as an attacker, assets, they're not a list. They're a set of relationships best described by a graph. And this concept, it's not new. I mean, as attackers, we stole passwords 20 years ago and we hopped through things. But the tools to visualize both offensively and defensively and then prioritize our remediation efforts, those have improved. This first graph here in the upper left is one a former coworker of mine made probably more than a decade ago. In it, each tiny blue dot represents a system at the target network. Each red box is a unique local account credential. The giant Pac-Man thing that you see, that exists because there are 1,000 systems that have the same local administrator password. A compromise of any single one of them is effectively a compromise of them all. The screenshot on the other side is that of modern free and open source Bloodhound. It's prettier than the first, and it shows more than just local accounts, but the idea is the same, right? It's how do systems and accounts link in ways that we can abuse them? So when we start to combine these kind of individual attack components, we get an attack path graph that we can actually visualize. So in the earlier example, I discussed an attacker gaining access to Citrix from the internet. They broke out of some published application, they elevated rights. They then stole credentials from that host and identified where they might be useful. And they hopped and moved laterally across the environment, ultimately finding a domain admin credential to steal and owning the entirety of the domain. If we look at it a different way, in a second path, maybe the attacker phishes the end user. And in this scenario, the end user has local admin rights over their respective workstation, which is very common still in organizations today, and it makes the attacker's life all that much easier. And then let's assume that that workstation was spun up from some gold image, some template, right? And because of that, the built-in administrator account is shared with every other thing spun up from that template, allowing the attacker then to hop through them. And in this scenario, let's assume that they ultimately landed on the workstation of a help desk member. And in most organizations, the help desk is looked to and delegated rights to provision and reset other accounts. So here, in our scenario, we can take over the admin account of somebody in charge of the enterprise password vault, which then contains the keys to the kingdom, right? So we can extract other credentials, maybe domain admin, and it's game over. So what we have are two starting point, or the same starting point and destination point, but two distinct paths between them. In any place you go, likely if you pick these 2 points, there's going to be a lot of different paths through them. So at my work, we invest a lot of effort into penetration testing and offensive exercises. Our goal is to graph out potential attack paths and then look for ways to prune those graphs. And our efforts, well, they can be boiled down into a couple of different options. The first is, how do we map and prioritize choke points that large numbers of attack paths might flow through? Secondly, how do we identify singular controls that, if implemented, would eliminate the largest number of graph edges? Admittedly, when we were first building our environment, we had graphs that looked like the problem one. So let's walk through now a couple of the choke points and edges that we tackled to fix our graph problems. We addressed this first choke point by ensuring that privileged accounts, such as domain admins, can only be updated by similarly privileged users. In our environment, it's members of our operations center who are delegated rights to reset and provision most staff accounts. However, it's only a subset of the Windows admins that can update similarly administrative level accounts. And then we take it further and we implement processes that manage the Active Directory account ownership, and that's to fix the problem where an account that creates another account retains ownership of it under the hood indefinitely. So in our environment, we don't have your traditional workstation. For us, it's Citrix that fills that role. And at any given time, we might have 250,000 concurrent Citrix sessions. It is by far our biggest attack surface. It is the most likely point of ingress, and it's the start of most paths in our graph. We invest a lot of effort into hardening Citrix against the breakout attacks that I showed earlier. And this includes application control, where we restrict which processes can be run to only those signed by trusted sources. And then we take it a step further and limit that to a subset of those processes, because we want to avoid the problem called living off the land, right? Where an attacker might abuse a normally trusted signed tool such as PowerShell. And we also disable any unused native functionality. For example, that whole drag-drop action that we saw earlier, that's ripped out. Services like the print spooler, task scheduler, they're also crippled. It's by turning off that which we do not need that we can avoid the impact of a lot of these 0 days. Now, defeating 100% of Citrix breakout attacks, it's not realistic, right? And our goal then is just to make that initial compromise as hard as possible. We want to make the attacker really work for it, because if they have to, they're going to trip a lot of alarms along the way. And just as important as stopping that breakout, well, it's our ability to detect and contain the malicious user. Now, there's always going to be some way into a network. The key then is to break up paths sufficiently enough to contain or slow the attacker and provide us with an opportunity to detect them. And the first step we took to reducing our edges was just to eliminate the sharing of local account credentials, right? We wanted to avoid that Pac-Man problem seen earlier. And we did it just using Microsoft's Labs. It's a free and effective tool that sets a fully managed random password on each local administrator account. We then looked at how we could sever edges between different groups of systems. And we implemented logical credential tiers to help define what accounts can have administrative access to what class of server. This here is Microsoft's graphic of their classic 3-tier model, and it essentially mirrors our own implementation. In it, tier 0, that top layer, that is the most privileged, highly sensitive tier. It contains things like accounts like domain admin and servers like domain controllers or password vaults. Tier 2 is your most at-risk layer. It's systems that have interactive end user logons, such as workstations, or maybe our internet-facing web servers. And then tier 1 is everything in between, application servers and the like. And the basic rule to the tiering model is that if you have an account with administrative rights in a given tier, that account can only be used within that tier. For example, a domain admin account, it's used to log into a domain controller. It can never be used to log into something in tier 1 or tier 2, because if it was, its password would be in memory or somewhere that could be stolen if that machine was popped and used to elevate rights in the environment. The final step we used to carve up our network and sever edges was through microsegmentation. So in security, there's this classic M&M analogy used to describe the traditional corporate network, right? The internet firewall provides this hard outer shell, but inside it's soft and gooey. Now I might have the analogy slightly wrong because most M&Ms aren't soft and gooey, but nonetheless, it still has always stuck with me, right? Because as an attacker, if you get past that internet firewall and you're inside the environment, you're generally free to move about and attack. With microseg, though, we can be way more granular in our network controls. The firewall rules, they're now applied at the asset itself rather than out at the network edge. And it allows us to define groups of assets and what they can talk to and how they might be able to talk. For example, we can say our Citrix server, well, it can talk to a specific file server on a file sharing protocol, or maybe it can talk to an operational database on a database protocol. But then we can layer on this default deny rule, where things that are not explicitly allowed are implicitly denied. So that brings us to the end of my talk. So my goal here was to share a little bit about my transition from red to blue, and then how we attempt to combine the two perspectives to protect our systems. And I work in a complicated environment with a lot of controls, right? And I'm biased, but I strongly believe that our most effective controls are the ones that we developed in response to offensive security testing. And quickly, before I go, I want to make one quick plug. So, like most of the world, we are actively looking for experienced security professionals. So if you're out there and you're a pen tester who wants a more purple role, and you live in Madison or willing to move there, and you want to work in a complex environment with meaningful data and make a difference, please talk to me. That's all I got.